Okay, so for this one, scale's important. Okay, there's a lot of backtracking that happens in this particular question. So my first vector is 750 meters, and it's definitely the longer of the two, and it is 30 degrees west of north. So when I'm drawing my diagram, I always draw my reference line in the direction of the second direction I was given. All right, so that's going to be west of north. So I'm going to draw north, like so. I'm going to go 30 degrees west of that. This is 750 meters. This will be its x. This will be its y. Okay? And then I can draw my second one on the head of my first one. Now it's 300 meters at 18 degrees south of east. Now this line is much shorter, and I need to keep that in mind. It's half, less than half as long as this line. So scale is important. Okay? So when I draw this, okay, I'm going to draw my reference line east, and then I'm going to go 18 degrees south of east for 300 meters. Now, just as a reference here, just so that I get this right with my scale, because this is a 30-degree angle, this side right here is 375 meters long. So when I draw this vector, I know it's only that long. Okay, this is a really easy diagram to screw up. Okay, because our assumption is that looks too short, and we want to draw it out here. Okay, so it's not that long, right? And all I did was kind of check in my head. All right, how long is this side of the blue triangle, so that I have an idea where to draw my green line. Okay, and so I just went, all right, I know the sine of 30 is 0.5, which means this side, okay, x is half as long as this, which is 375 meters. The line I'm about to draw is only 300 meters long. It definitely can't go past there. Everyone follow what I did? Right? Because, like I said, scale's important. I don't want my math to tell me a different story than my diagram. All right, so now I've got that. This will be x, this will be y, this is 18 degrees, right? And this is 300 meters. So that means my resultant looks like this. This is theta, okay? This will be my displacement, x and y. Hey, everybody with me so far? So I got to start calculating all my x's and y's. So blue x is opposite the 30-degree angle, and I already did that calculation in my head, which is dangerous, but I did. Times 750 equals 375 meters west. Okay, and then for y is the adjacent side in this triangle, so cos of 30 times 750. So that side's going to be 649.52. meters north. And then I can move on to my green triangle, which is much, much smaller. Okay. Green x is adjacent in this one to my 18-degree angle, so it'll be the cos of 18 times 300 meters. So 285.32 meters east. Y is opposite my 18-degree angle, so I'll be using sine to get it. Sine of 18 times the hypotenuse, 300. All right, it's 92.71 meters. And that's south. Okay, now I have all my x's and all my y's. Now I can find my resultants triangle. All right, so my resultants x is very small according to my diagram. Okay, red x still ends up slightly west of my origin, so I'm going to make the west, the positive one, 375 minus 285.32. Alright, so we got 89.68 meters west. And then my y, I have one, the north one is the much bigger of the two, so I'm going to make that 649, the positive one, minus green y, which was only 92. All right, 556.81 meters. North. All right, what do I do with those two red numbers?
You use Pythagorean theorem to find the displacement.
Right, my next step is to find my displacement's magnitude using Pythagorean theorem. So 89 squared plus 556 squared. Is 563.99 meters. All right, what's my next step? Lindsay, what do I do next? Something I still haven't found. Right, I got to find the angle here. I've got y, I've got x, so I can use trigonometry to get that. So theta will be tan to the minus 1, okay, of y over x. So y was the x over y, because x is opposite, sorry. So that'll be the 89 over 556. Okay, that seems to fit with my diagram. It's a pretty small angle, right? 9.15 degrees. Actually, 9.149. I should write them all just in case. Okay, degrees, and for me, that's going to be west of north. Okay. Now, I don't need to do the significant digits yet, because what do I have to do now? I have to find the velocity. Okay? They told me that this whole trip takes 380 seconds. What I have is the displacement. I need to know the velocity. Velocity is displacement divided by time. So in this case, that's going to be 563.99 meters at 9.149 degrees west of north, divided by 380 seconds. So take that number there and divide it by 380, and I get 1.48 meters per second. At 9.149 degrees west of north. And now I would do my significant digits. Right? According to this, I have 2, because the 18 degrees only has 2 significant digits.
So at the bottom of the worksheet, for the 563 point, the velocity calculation,
Yep.
if we were getting method marks in that situation, would we be marked off for not putting the at 9.149 degrees west of north?
Right in here?
Yeah.
No, I just did that to make a point.
Okay.
No, I wouldn't expect you to write that in I was just illustrating that this carries over to this, because it was something we talked about with boat questions yesterday, right? We can only use things that point in the same direction, and that velocity and displacement always have the same vector. So they were still going through my head, and so I was just trying to make a point of that. But no, I would never expect you would go to this bother in your method. Okay. All right, so I have 2 significant digits, so we're looking at 1.5 meters per second at 9.1 degrees west of north, or at 81 degrees north of west. Both of those have 2 significant digits, and they're both the same vector. All right. Okay, so that one take quite a while. That's a mean question. Okay, but the reason I gave it to you is I think we still need practice with the diagrams. Okay, just in kind of walking around and looking at people's drawings, I'm still sensing that that's giving us some trouble. Okay, if you're consistently struggling with the diagram, try the separate triangle method. Okay, just like give it a try on a question and see if that makes a bit more sense. It does kind of free you up from the commotion of the big diagram. The big thing here, guys, and I can't stress this enough, is when you're drawing out your vectors, okay, if this is my vector, 20 meters at, let's say, 50 degrees south of east, okay, if I'm going to draw that vector out, my reference is east. So I draw my reference line east, then I go south of that 50 degrees, okay, which is more than halfway. That's terrible, that's not more than halfway. That's probably too much, probably went too far. Okay, 50 degrees, 20 meters. Okay, we have to have some way of getting that diagram and that arrow to point the right way. Right? And it might be helpful to you on every question to do this. I see people do this too. They go N-E-S-W, and then they're like, okay, east, south of east, boom. Okay, that's what my triangle should look like. Then they draw the triangle. Okay, or they do the hand thing. They point their hands east, they go south of east. Okay, there's my triangle. Whatever works for you. Okay, but we've got to make sure we're getting those diagrams done correctly. You guys are fine at the math. It's like I said, the math isn't the hard part of this. Okay, it's just trig, and it's the same trig every damn time. Okay, we just have to get the diagram right. Okay, and that's going to be our big challenge. Okay, I want you guys to try this one. Now, it says it's a boat, but it's not a boat question. Okay, because this is a boat that's sailing, not rowing. Right, so this is like on the ocean. Okay, so it's 2 trips. Okay, so it's very much like the one we just did. Okay, in fact, it does even have that same second part here where you're asked to calculate the velocity after the fact. Okay, so calculate the displacement first and the velocity second. I'll give you a few minutes, then I'll draw the diagram just so you don't get too far using the wrong picture. Okay, so first we are going 20 degrees east of north, and then we're going south of east. So luckily everything's east, okay, at least that part of it is all the same. So we've got east of north, so I'm going to draw my reference line north, right, like so, and 150 kilometers at 20 degrees east of that. So this will be X, this will be Y, that's my 20-degree angle, and this will be 150 kilometers. Well, that's, boy, my penmanship is awful. My grade 6 teacher was right. Of course, I do stand by the fact that I told her in grade 6, handwriting won't be important. Everyone will type stuff on computers. And here I am, writing on the board. Okay, so next vector. We've got 265 kilometers at 45 degrees south of east. So my reference line is east. So I draw my reference line east. I'm going to go 45 degrees. Okay, that's about 45. Well, that's not where that was supposed to go. Okay, 265 needs to be longer than that. Okay. All right, so this will be x, this will be y, and this will be 265 kilometers. And then my resultants will go like so. All right. Now I drew this, I think the other way, like I drew it this way, but I think the answer that's written there, it's drawn over top of the diagram. So I'm gonna get the complementary angle. Okay, I'm not gonna get 11 degrees south of east, I'm gonna get 79 degrees, or sorry, 79 degrees east of south when I do this, but that's fine. Okay, y, x, and this is d. All right, that's what we're looking at, guys. I'll give you a little bit more time to get ahead of me. All right, guys, I'm gonna get the x and y components up here. All right, just so we've got those. So for red x, we are looking at the opposite side. Okay, it's opposite the 20-degree angle. All right, so we're gonna have the sine of 20 times 150. And so 51.3 kilometers, and that is east. Okay, and then y is the adjacent side, so it'll be the cos of 20 times 150. 140.95 kilometers north. Then for our green triangle, have I saved us a little bit of work with the green triangle? What did I do that would save us work?
You made the angle 45 degrees.
Yeah, I made the angle 45 degrees, which means x and y are this, right. Sorry, x is actually going to be the cos, not that it matters. Cos of 45 times 265. Okay, so it's 187.38 kilometers, and that is east. And that means that y is also 187.38 kilometers south. All right, so obviously we go south more than we go north, and both vectors go east. Okay, so all we have to do is add them together. So to get our blue triangle here, so blue x is going to be red x plus green x. So that'll be 51.3 plus 187.38. So 238.686. Kilometers east. And then y, we're going to have the 187.38 minus the north part, which was 140.95. 46.43 kilometers south. Okay, now that I've got those, now I can find my overall displacement using Pythagorean theorem. So 243.16 kilometers is how big D is. I'm gonna find theta, okay? Theta is gonna be tan to the minus 1 of x, because it's opposite my angle, over y, which is adjacent. So that'll be our 238 divided by 46, which is gonna give me like 89 degrees. Sorry, not 89, 79 degrees, 78.99, so. Degrees, and that is gonna be east of south. Okay, question asks, that's part A, okay? So we're only gonna have 2 significant figures, so this answer is actually incorrect. Okay, it should be 2.4 times 10 to the 2. Kilometers at 79 degrees east of south, or at, we said 11 degrees south of east. Okay, either one of those would be correct. Now, here's something we need to know about significant digits. If I have a part A and a part B, and I have to use the answer from part A to calculate part B, I use the significant digit rounded version. Okay, I'm not carrying over all of the digits into it. I use that number when I do my calculating, and it will affect my significant digits for part B. Okay, so it would be possible to have different significant digits for part A and part B on a question. It would be possible for that to happen. In this case, it won't happen because that'll be our lowest number, but it can happen. So for part B, it's asking us, this whole trip takes 12 hours. Okay, so we'll take our 2.4 and divide it by 12, okay, which should give us our 20.3 kilometers, actually just be 20 kilometers per hour at 11 degrees south of east, okay, or at 79 degrees east of south. Okay. Everybody all right with that? Okay. Take a little break. I've been doing nothing but vector addition since we started today. Okay, take a little break. Take 5 minutes. Okay, so it starts out with velocity vectors, and then after that asks you to calculate the displacement from there. Right? So it's a little bit of a reversal of the previous question. Does the fact we're given velocity vectors change how we do this? All right, have at her. I'll put the diagram up in a few minutes. Okay, let's look at our diagram here. So our first one is 40 degrees west of south. So I'm going to draw a reference line that's south. I'm going to go 40 degrees west of that. And this will be 620 kilometers per hour. Okay, and this will be x, and this will be y. And then for our next vector, it is 500 kilometers per hour at 75 degrees east of north. So I really didn't position this very well. A little bit further down. Okay. So it's east of north. So I'm going to draw my reference line north. Okay. And I'm going to go 75 degrees east of that. All right. Well, that's like, I drew that way too long. Okay, it's going to look like this. Yeah. Yeah, I think that's about right. Yeah, so that's going to make that triangle right there, where that angle is 75 degrees. This is x, this is y, and this is 500. I think my scale is decent there. My 500 is definitely less than the 620, and I got a 75 degree angle there, so okay, that seems about right. But it's a pretty crazy diagram because there's a lot of backtracking. Okay, but again, scale is important. Whoa, that was quick. All right, give you a few more minutes there, guys. Sorry, guys. We need this. Okay, so that'd be our average velocity, our overall resultant velocity, okay, y and x, right, and that's our resultant there. So we got to do our blue triangle first, okay, and for our blue triangle, okay, blue x is the opposite side, so I'll be using sine of 40 degrees times 620 kilometers per hour. Sine of 40 times 620 gives me 398.53 kilometers per hour, and that will be west. Okay. Y is the adjacent side to that 40-degree angle, so that's going to be cos of 40 times 620. And that's 474.95. That's kilometers per hour south. Okay, same thing for our red triangle now. Okay, and our red triangle is right here. If we're looking for x, x is opposite the 75-degree angle. So red x will be the sine of 75 times 500. So 482.96 kilometers per hour, and that will be east. And y is the adjacent side to the 75-degree angle here, so that'll be cos of 75 times 500. So 129.41 kilometers per hour, and that one is north. All right, so now we've got all of our x's and y's. Now we can calculate our resultants x and y. Okay, so our resultants x ends up going east. So I'm going to take the 482.96 and subtract the 398.53. All right, so 84.43 kilometers per hour east. And for y, we end up north of where we started, so I'm going to take, south of where we started. So I'm going to take the south, which is the 474, and subtract the north, which is 129. $345.54 kilometers per hour south. Okay, now that I've got those, now I can find the magnitude of my overall, it's not displacement this time, it's velocity. Okay, so that's going to be 345 squared plus 84 squared. All right, so we're looking at 355.70. 355.70 45.70 kilometers per hour. Okay, and then we gotta find theta. The way I drew this triangle, okay, if I wanna find theta, y is my opposite side, x is my adjacent side. So tan to the -1 of 345 divided by 84. So we're looking at 76.27 degrees. And that will be for my diagram south of east. Okay, so my overall velocity, and I'm looking at how many significant figures, it's 2. Okay, so my overall velocity here is going to be 3.6 times 10 to the 2 kilometers per hour at 76 degrees south of east, or if we drew the triangle the other way, it would be 14 degrees east of south. Right? So that's our overall resultant velocity. The second part of the question asks us to calculate the displacement if the plane flies for 7.5 hours. All right, so V equals D over T. I'm solving for D this time. So V times T equals D. That'll be our 3.6 times 10 to the 2 times, what was it, 7.5? 7.5 hours. So, 3.6. Oops, brackets. Okay, times 7.5. All right, 2,700 meters, 2,700 kilometers, sorry, 2,700 kilometers. But we only have 2 significant digits, so 2.7 times 10 to the 3 kilometers at 76 degrees south of east, or at 14 degrees east of south. Okay? That's as hard and involved as they will ever get. Okay? I will make an easier one on the quiz tomorrow, so it's a little shorter. All right, good work today, guys.